Good evening, sir.
Good evening. Just wait for a few minutes.
Okay, sir.
Okay, so let's start. In last class, we had started non-uniformly accelerated motion. Okay, for which I defined you some problem. I'm giving you f t is equals to root of x plus 3. This is one type of question. And t is equals to some alpha times x squared plus beta times x. Find acceleration in each. Try to solve.
Okay, sir.
Alan, I have given two questions. In this, we have to solve acceleration. Try to find out. Should I give you some hint, Ifra?
My acceleration is coming 2 meter per second square for the first part.
Okay. Try to find for the second. Alan, any problem?
Sir, can you give hint?
Okay. So for any expression, let's say for the first part, we have t is equals to root of x plus 3. To find acceleration, you must have to define velocity first. And velocity is nothing but dx over dt. So first of all, try to rearrange this equation. Then keep x to one side and rest of the whole term to the other side. So on rearranging, t is equals to root of x plus 3. Move 3 to the other side. So you will get root x equals to t minus 3. Here we have square root. So on moving this to the other side, you will get t minus 3 whole square, or I have squaring both sides. Now, if you expand this term using a minus b whole square identity, so it will be a square minus 2ab plus b square is equals to x. Now differentiate it, you will get velocity. Dx over dt will define your velocity. And then again, differentiating velocity will give you acceleration. Is it clear, Alan?
Yes, sir.
Okay. Try to differentiate this part, you'll get velocity, then differentiate it again, you will get acceleration. Ifra, just check your calculation.
Okay, sir.
Alan, just see, we have t square. So on differentiating it, you will get 2 times t minus 6 into t. 6 is any coefficient and t having exponential 1. So on differentiating it, you will get 1 plus 9, which is any constant term. So differentiation of any constant term will be 0. So this will define you velocity. So v is equals to 2t minus 6. Is it clear, Ellen?
Yes, sir.
Now, if you differentiate it again, dv over dt, you will get acceleration. So it will be 2, t having exponential 1. So using the rule, if you have x raised to n, so on differentiating, it will be n x to the power n minus 1. Similarly, for this part, we have t raised to 1, so it will be 1 t raised to 1 minus 1 minus 6, which is any constant term. So differentiation would be 0. On simplifying it, you will get 2 meter per second squared as acceleration. Is it clear?
Sir, but in dx by dt, like t square is becoming t and how t is becoming 1.
No. Simply for, let's say for this part, t having exponential 2. So it will be on differentiating n x to the power n minus 1. So it will be 2 times t raised to 1 using this formula. Okay.
Okay, sir.
Similarly, in this part, we have t raised to 1. So on differentiating it like this, you will get t raised to 0, which will equals to just 1. So you will get 6 only. Is it clear?
Yes, sir.
Okay. But in this second example, we can't separate x and t to one side like we did in this part. So how to define acceleration? Just see in this example, we have t as x dependent term. So first of all, differentiate it with respect to x as t is x dependent. So you will get alpha x square. So on differentiating using this rule, it will be n x raised to n minus 1 plus beta x raised to 1. So it will be 1x raised to 1 minus 1. So if you simplify it, you will get 2 times of alpha x raised to 1 plus beta x raised to 0. So it will be 1. Now, in left-hand side, we have dt over dx as velocity equals to dx over dt. But in this part, we have dt over dx. So we can write it as 1 over velocity. Ifra, is it clear?
Yes, sir.
Now, if you shift
Yes,
this,
sir.
if you shift this particular term to numerator, you will get velocity is equals to 2 alpha x plus beta in denominator. So on moving it to numerator, you will get minus 1 as exponential. Alan, is it clear?
Yes, sir.
Okay.
Sir, but in the first question, x
Yeah.
is equal to root x is equal. Okay, you squared that one.
Yeah.
Like root of x is equal to t minus 3. So x is equal to t minus 3 whole square, right?
Whole square. I've taken squaring on both sides, or you may say you have shifted root 2 to the other side, it will become square.
Okay.
Okay, now how to differentiate this term? I'm defining you using example. There is a rule which is called function of function, for which we use chain rule of differentiation. So first of all, how do you judge any function to be composition of different function? Let's say if you have y is equals to x squared plus 5x and whole raised to 5. So in this part, we have two different terms or two different functions, and we can't separate them individually. First is the base term, that is x squared plus 5. So we call it as algebraic function. And next is the exponential over whole. So we can call it as exponential function. So in this expression, we have mainly two different functions and they are combined together and we can't separate them individually. Alan, is it clear?
Yes.
Okay. So for any expression which having composition of function, just use chain rule. So what it defines? So if you have to differentiate this term, dy over dx. So on the basis of arrangement of this particular function, take the outermost function as 1. So in this part, we have exponential. So it will be first. Innermost after this particular function will be numbered as second function. So it will be 2. So on differentiating, differentiate the outermost part first, then move to the inner side. So in this part, we have to differentiate the outermost, that is exponential, keeping the rest of the whole term to be as it is. So exponential on differentiating will be n x to the power n minus 1. This is how we differentiate any exponential term. And rest of the term, that is in base term, x squared plus 5x will be remain unaffected. Ifra, is it clear?
Yes, sir.
Then differentiate the next innermost function. So in this part, we have algebraic function in which first is x squared. So it will be nx to the power n minus 1 plus 5x, 5 being constant, take it outside, x having exponential 1, so it will be 1x to the power 1 minus 1. Now simplify whole term, you will get 5 x squared plus 5x to the power 4 times 2x plus 5 as whole differentiation. Alan, is it clear?
Yes, sir.
Similarly, just see in this expression, can we say this is nothing but composition of two different functions for velocity? Ifra?
Yes.
So which are the two
Yes.
functions in this particular part? So you will say first is algebraic function, that is base, and second is exponential function due to this. So take the outermost function as first, inner to that particular term as second. Now differentiate it using chain rule. So as velocity is x dependent, so dv over dx is equals to, first is exponential, so it will be n x to the power n minus 1. Next is algebraic function, which is 2 alpha x. So 2 alpha being constant, x having exponential 1. So on differentiating it, you will get just 1 plus beta, which is nothing but a constant term. So on differentiating, it will be 0. Write the second function as it is for the first part. So it will be 2 alpha x plus beta. Alan, is it clear?
Yes, sir.
Ifra, any doubt?
No, sir.
Now we have to rearrange this particular term to get acceleration. In last class, I defined you whenever you have velocity as x-dependent function. So acceleration would be equals to v times dv over dx. So v is as it is, dv by dx is this term. So we can rearrange it as minus into 2 alpha. So it will be minus of 2 alpha. This whole term is 2 times of alpha x plus beta raised to minus 1 and whole raised to 2. We can write it like this. Now see this particular bracket and this particular term. Are they equal? This term and this term. Ifra, are they equal?
Sir, can you please repeat again because today my network is not good, so the voice is cutting.
Okay. I've just put the value of each term according to this formula. Acceleration is v times dv over dx. And we have calculated dv over dx as this much. So if you put in this expression, you will get 2 alpha times minus, so it will be minus of 2 alpha, 2 alpha x plus beta whole raised to minus 2. So we can write it as minus 1 to the power 2. As we know, x to the power m, which is further power n, so the power to the power get multiplied. So we can write minus 2 as minus 1 into 2. Now this expression and this expression is same, so it will be just velocity. So on rearranging, you will get minus of 2 alpha, and this is velocity having square, so it will be v square. So on combining whole term, it will become vq as a. Is it clear, Alan?
Yes, sir.
Okay, just write it down. written?
Done.
Okay.
Done, sir.
We have A as acceleration. So find the value of velocity for which acceleration is 0. Try to solve. Alan, any doubt? Let's say in this part, we have A as acceleration. And we have to calculate velocity when acceleration is 0. So put this term equals to 0. So it will be A naught 1 minus t divided by 2 is equals to 0. On solving, you will get t is equals to 2 seconds. So at this time, acceleration will be 0. Now we have to calculate velocity for this instant. So we can write acceleration is equals to dv over dt is equals to a naught minus a naught over 2 into t. Move this dt to the other side. You will get a naught into dt minus a naught over 2 t times dt. integrating both sides, you will get velocity. If you have x raised to n times dx, so integration will be x raised to n plus 1 divided by n plus 1. Okay, Fra. And integration of dx will be just x. Alan, is it clear?
Yes, sir.
Try to simplify it. On simplifying it further, dv will become v is equals to a naught, dt will become t minus a naught by 2 dt having exponential 1. So using above formula, you will get t1 plus 1 divided by 1 plus 1. So it will be a naught into t minus a naught by 2, and this will become t square by 2. We have to put t as 2 seconds in this expression. So on putting t is equals to 2 seconds, velocity will be 2 times a naught minus a naught by 4 into 2 square. So 4 and 4 will cancel out. 2 naught minus a naught will be just a naught. Meter per second. Ifra, is it clear? Alan, is it clear?
Sir, how did you get P is equal to 2 seconds?
We have given in the question to find velocity when acceleration is 0. That's why I have put acceleration is equals to 0. And on simplifying it, we get t is equals to 2 seconds.
Yes, sir.
If you move a naught to the other side, it will become 0. So what we're left with? 1 minus t over 2 is equals to 0. Move t by 2 to the other side, it will become plus. On moving 2 to the other side, you will get t is equals to 2 seconds.
Okay, sir.
Let me solve it. 1 minus t over 2 is equals to 0. So it will be 1 minus t over 2, or t is equals to just 2 seconds.
Okay.
Have you written till this?
Yes, sir.
Yes, sir.
Now, using this calculus, we have to derive equation of motion. So next is equation of motion using calculus method. Let first equation is v is equals to u plus at, which is called velocity time relation. Velocity and time will define you acceleration. So let's say acceleration is equals to dv over dt. We have to calculate velocity, so move this dt to the other side. So it will be dv is equals to a times dt. Integration, integration. Now to define this particular integration, we have to take limit first. At t is equals to 0 or initial time, velocity of body will be u, and some later time t, velocity would be equals to v. Now on putting these terms in this part, you will get dv integration u to v is equals to a being constant, so take it outside as coefficient, integration dt from 0 to t. Now on solving dv, so it will become v upper limit lower limit is equals to a dt on integration will give you t lower limit upper limit. Put the value of v to be upper limit, so it will be v. Similarly lower limit, so it will be u and negative sign in between. Similarly for this part, put the value of t to be upper limit, so it will be t, and lower limit as 0. On simplifying it, you will get v is equals to u plus a times t. Alan, is it clear? Okay, just write it down.
Done, sir.
And so,
Next is S is equals to ut plus half at square. So this is called displacement time relation. Now for this part, displacement and time will define your velocity. So velocity will be equals to dx over dt. Now in this above expression, there is no any term regarding v. So we have to convert v in terms of u and a using first equation of motion. We can write it as dx is equals to v times t. If you put the value of v to be u plus at using equation first, so it will be u plus at. Now expand it, so it will become u dt plus at dt is equals to dx. Integration, integration, integration. Now to define this integration, we have to take limit. Let's say at t is equals to 0, displacement of body will be 0, and at some later time, displacement of body is s. So if you put all these terms in this part, you will get dx integration from 0 to s is equals to u integration dt from 0 to t, a into t dt integration from 0 to t. For the first part, we have dx. So on integration, it will give you x, limit from 0 to s, u dt on integration will give you t from 0 to t, plus a, t having exponential 1. So on integrating it, you will get t square divided by 2, limit from 0 to t. Now put the limit, upper limit and minus lower limit. So it will be s minus 0. U, put the upper limit to be t, lower limit 0. So it will be t minus 0. A over 2 as coefficient or constant terms, take it outside. T squared, so put the value of t as this term, so it will be t squared. And put the value of t to be 0, so it will be 0 squared. So on solving it, you will get s is equals to ut plus half times at squared. So this will be your final expression. Ifra, is it clear?
Yes, sir.
Okay, just write it down.
Done.
Thanks, sir.
Next is v squared is equals to u squared plus 2as. It means velocity displacement relation. There is no direct relation to define velocity and displacement. So first of all, we have to relate them. So let's say acceleration is dv over dt. In this part, we have time, but for this expression, there is no any time-dependent term. So we have to convert it in terms of displacement. For this, just multiply and divide by dx to this fraction. So it will become dx over dt times dv over dx. I have just switched this term to this side and this term to this side. Now this whole term will become velocity times dv over dx is equals to a. That's why we are using acceleration is equals to v dv by dx when velocity is x dependent function. Now to integrate this term, move dx to the other side, you will get a times dx integration is equals to v times dv integration. Now we have to take limit to solve this. At initial term, let's say t is equals to 0, so x will be 0. Velocity of body will be u, that is initial velocity. And at x is equals to some displacement s, velocity of body will be v. Putting these limit in this expression, you will get a from 0 to s dx is equals to v dv from u to v. So a is constant, dx on integration will give you x, limit from s to 0. V having exponential 1, so on integrating it, it will become v square over 2 from lower limit to upper limit. Now if you put the values of x is equals to s and x is equals to 0, so it will be s minus 0. V as upper limit, so it will be v square. V is equals to lower limit, so it will be u square minus divide by 2. Move this 2 to the other side, so it will be 2as is equals to v square minus u square, or on rearranging, you will get v square is equals to u square plus 2as. Helen, is it clear? So this is third equation of motion. Just write it down. Okay. So this is all about non-uniformly accelerated motion. Next term is graph related to this. In graph, we mainly define two terms. One is called slope and next is area. I'm giving you some relation how to define it. This is x-axis, y-axis. And there is a line from this point to this point, having coordinate x1, y1, and this having coordinate x2, y2. So if you have to calculate slope of this line, draw a horizontal line to this and vertical line to this. So this inclination theta may be calculated using these coordinates as this point will be x1, this point will be x2. So if you subtract these two terms, you will get x2 minus x1 from this to this. Similarly, this will behave as y1 and this will be y2. So if you subtract these two terms, you will get y2 minus y1 to this part. Now, in this triangle, we have both base as well as perpendicular. So if you want to calculate slope, which may be represented by m, or it will be equals to tan theta. So it will be perpendicular divided by base. So it will be y2 minus y1 divided by x2 minus x1. So this is how we define slope or inclination of any line with respect to x-axis using coordinate system. Is it clear?
Yes, sir.
But suppose you have any curve like this, and you have to define slope to any given point. So to define slope on any curve, just draw tangent to that given point. So let's say at this point, it will be along this path. Now draw a horizontal line to this. So inclination from this line to this tangent will define you slope of curve at this given instant. Similarly, if you draw a tangent to this point like this, draw a horizontal line and take inclination. So this will define you slope of curve to this particular point by this inclination. So whenever you have to calculate slope to any curve, just draw tangent to that given point and define its inclination with respect to x-axis. So this will be tangent. Using equation dy dx, that is differentiation of y with respect to x, will define you tan theta, or for any curve, it will define you tangent to the curve. Ifra, is it clear?
Yes, sir.
Okay.
Done, sir.
Okay, next is suppose if you have any curve and you have to calculate area related to this, draw a line to this point. So it will be x1 to this point. So it will be x2. So difference of these 2 points will define you its diameter. Similarly, if you draw a line to this, it will define you y1 and y2. If you difference these two terms, you will get diameter along y-axis. So for any curve, whether it would be circle or ellipse, whenever you have to calculate area, it will be pi times r1 into r2. R1 will be radius along x-axis. So it will be calculated using x2 minus x1 divided by 2. Similarly, R2 would be equals to y2 minus y1 divided by 2. Alan, is it clear?
Yes.
Similarly, this is y-axis and this is x-axis. Suppose this is a line and this is another line, and join like this. So this particular line would have length as y1. This will be y2. Coordinate of this particular point to be x1 and this to be x2. So this particular curve or geometrical figure is termed as trapezium. Now for area of trapezium will be half times sum of parallel sides into perpendicular separation between them. So if you put the values, you will get half parallel sides is y1 plus y2 and separation between them is x2 minus x1 as its area. So in this term, y1 and y2 is parallel to each other. So this is how we define area and slope related to different curve. Just write it down. I'm giving you some more concept.
Done, sir.
Done, sir.
So on the basis of this, first thing is slope of first distance time will define you speed, which is scalar quantity and can never be negative. Second is displacement versus time. So it will be velocity, which is a vector quantity. So it will maybe positive, maybe negative, and zero. Slope of speed time and slope of velocity time. Both will define acceleration, which is again a vector quantity. So it will maybe positive or negative or zero. So on the base of slope, we may find these terms related to this chapter. Next is area under. First is acceleration versus time. So it will define you velocity, but if you take mod of it, that is only positive value. So it will define you speed. Next is velocity versus time. So area under velocity time will define you displacement, but velocity time mod will define you distance. And last, speed versus time will again define you distance. So we can define these quantity on the basis of slope or area under. Is it clear? Just write it down. I'm giving you some examples related to this. Find acceleration first for AB and second for BC. So let's say we have velocity versus time graph. So slope of velocity versus time will define you acceleration. And since there's a straight line, so for a straight line using coordinate system, we can calculate slope. So first of all, try to define coordinate of each part. Let's say for A, it will be 0 and 8. Similarly for B, it will be 4 and 10. And for C, it will be 6, 0. Now, as we are progressing along this direction, so this will be termed as x2, y2, and this will be termed A as x1, y1. Using the above formula, slope for AB will be y2 minus y1 divided by x2 minus x1. This will define you acceleration for path AB. Alan, is it clear?
Exactly.
Just put the values. Good, Ifra. So on going from A to B, y2 will be 10 and y1 will be 8. x2 will be 4, x1 will be 0. So you will get 2 divided by 4. So it will be 0.5 meter per second square. Similarly, acceleration for B to C. So coordinate of C will behave as x2, y2, and coordinate of B will now behave as x1, y1 as we are progressing from B to C. Good, Ifra. So it will be y2 minus y1 divided by x2 minus x1. So in this part, y2 will be 0. y1 will be 10. x2 will be 6. x1 will be 4. So it will be minus 10 divided by 2, or it will be minus of 5 meter per second square. Alan, is it clear?
Exactly.
Okay, just write it down.
Answer.
Okay. So this is all about this graph. Just revise this whole part. In next class, I will define you some more problem related to this, and then we will start chapter number 4, that is vector. Okay?
Okay, sir.
Okay, sir.
Okay then.
Thank you.
Thank you.